So first thing first, we have to run this cell to make sure that we have NumPy and Pandas available to us. Okay. So there are two categories of data model that Pandas offers us: Pandas series and Pandas data frame. Pandas series is what we have been discussing. Pandas series is like a one-dimensional NumPy array, okay, and all elements will have to be of the same data type, and it has one additional property that NumPy arrays do not have, and that is it has an index associated with each element. And if you do not provide an index yourself, then Pandas will automatically assign indexes going from 0 through n minus 1. Okay. And that's called implicit index. Then if you assign indexes on your own, that's explicit index. So if you have assigned explicit index, you can use both explicit index or implicit index to access and slice values from the series. And if all you have is implicit index, then you have to use only implicit index. Okay, and you can create Pandas series using PD dot series with uppercase S, PD dot series function, and you can supply a tuple or you can supply a list, in which case the tuple and list will be converted into a Pandas series. And if you provide a dictionary, then the dictionary keys will become the index values, and the dictionary values will be the values in the series. Then you can perform arithmetic operations. Okay, let's start from here. So it's a repeat of a little bit of what we had done previously. And you can do scalar arithmetic, okay, where you have a series and you have a single number. Okay, and then you can do arithmetic with it. So you can multiply all the elements of the series with this one scalar. Add, subtract, divide, raise to the power of, and so on. So here to illustrate these arithmetic functions, we're going to create a random series of numbers, and we're going to save that as S4, and S4 is a Pandas series, and the data type is automatically assigned, so it's an integer data type. Then you multiply by a scalar, you take S4 times 2, and then that times 2 will be distributed to all the elements in the Pandas series. So it's like a loop. It'll go through the loop, so that's the universal function. So it'll go through all the elements and multiply by 2. And here add 3, okay, so it goes through. And then you do 1 over S4, okay, so that's going to divide each element into 1. And you'll have, so in case any operation is not feasible, not permissible, then you'll have NaN as the answer for that. So if you take a square root of S4, then you see that negative numbers do not have a square root value, so you end up with NaN, and all the non-negative values you get a regular square root value. And that's your scalar. Okay. Now, arithmetic with more than one Pandas series. Okay. So here in NumPy arrays, okay, if the two arrays are of the same shape, then they are paired. The first item with the first item, second item with the second item, and so on. Okay. And if they are not the same, then you have the broadcasting rules, the 3 rules that we talked about. In Pandas series, it's not one-to-one paired by the index. Of course, if there is only implicit index, then it's going to pair by the implicit index, but it's going to pair by the index. So it can be, need not be just paired exactly the same, and here is an example of that. Okay, so you have two series here, S5 and S6. Okay, so that's your S5 and this is your S6, and we want to add S5 and S6. So you have S5 here and S6 here, and we want to add the two. Okay, and it can be any other operation, by the way. It need not be just plus. It can be divide, it can be to the power of, and so on. Okay. So what it's going to do is it's going to pair the index. So here, for the first series S5, these are the index values: Texas, Ohio, Oregon, Utah, and Ohio, California, and Texas are the index values for S6. So it's going to match up by, so it's going to take S5 and S6 and match them up with index. Okay. Sometimes an index you find in S6 you may not have in S5. An index that you find in S5 you may not have in S6. So in that case, any operation that you perform will result in NaN. But if an index is present in both S5 and S6, then the operation will be completed. Okay? So that's what you see here. S5 plus S6 will give you this. Okay? I did not have this image last time, and I'll make it available. You know, it's there now, so you can download the new copy of the class file and you'll have it. Okay? So S5 times S6, again the same thing. It will match up according to the index values and it will perform the operation.